Hello everybody, this is the notes for Algebra 2 Trig, section 8.7. Talk about simplifying radicals, adding, subtracting, multiplying, dividing, all that kind of stuff. So, take a second, copy down these couple formulas here. All right, this top one, there's a lot of detail in this. But basically what it says, if n is a positive even integer, so you're taking the nth root, like a fourth root or square root, because it's even, of a number that's raised to the same power, okay? Notice how the answer says it is the absolute value of a. So think about this. If we had the fourth root of a negative 3 raised to the fourth power, okay, you take a negative number to the fourth power, your answer is a positive value. In this case, we're talking about 81. So we're looking at the fourth root of 81. That is going to be 3. All right. So we plugged in, our a value was negative 3 for this problem, but our answer is a positive 3. Normally you look at it like, oh, the nth root of something raised to the n is just going to be that original number. Well, not when the case is positive even integer root and number raised to that power. You're just taking the absolute value. All right, so a little bit of detail in that one. And this bottom box here, these things go in both directions. All right, if you have separate nth roots of numbers, you can bring them together into a single nth root. Same thing with division. If you're dividing, if you have an nth root of a fraction, you can separate it. If you're dividing two of the same roots, quantities, then you can bring them together in one nth root. All right, so simplifying these. So we just have a square root here. What I'm going to do is, there's lots of ways you can think about this, but here's one way. I'm going to separate these into just their terms. They're not terms, bad terminology. Numbers and then variables. But I'm looking for perfect roots. Okay, I'm going back to this idea here. I want to have the nth root of a power to that same, or a number to that same power. So 81, I'm taking the square root, so I got a little 2 there, and we never write it, but 81 is 9 squared. Okay, x cubed is x squared times x. So again, this is the idea of what I'm looking for. I'm looking for that x squared. Because the square root of a square, those things will cancel each other out. That y to the fourth is y squared, and z to the sixth is z cubed squared. So now, when I take the square root of each of these things, I'm going to separate these. Square root of 9 squared, square root of x squared, square root of x, square root of y squared raised to the second power, and the square root of z cubed raised to the second power. So now, square root of 9 squared is 9. Square root of x squared, x. That square root of x does not simplify anymore, so that stays in the square root. The square root and the y squared squared, that's just a y squared. The square root and the square cancel each other out, leaving us with a z cubed. So we've got 9x y squared z cubed times the square root of x. All right. That was that problem. Now, for the cubed root, I'm going to do a very similar idea. The cubed root, 125 is a perfect cube. It's 5 to the third power. X to the sixth is x squared raised to the third power. Again, I'm taking the cubed root of things, and so I'm looking for quantities raised to the third power, so it's easier to simplify. That y has nothing to it, so it's just going to stay there. Z to the fifth is z cubed times z squared. So now, I take the cube root of each of these individual factors, I get 5, x squared. That y, it's got to stay inside the cube root. Z cubed, when you take it to the cube root, that's just a z, and that z squared, stays inside. It is not a perfect cube, so it just stays there. So our answer is 5x squared z cube root yz squared. Okay, that's one way to do these problems. All right, to simplify these things, well, similar idea.